science program called Fracking in Western Mass. What are the facts? Can everyone hear me? Good. My name is Aaron Felbel. I'm the circulation assistant here at the Sunderland Library, and I'm also a member of the other sponsoring organization, the Sunderland Energy Committee, along with Laura Williams, who will probably come here. There you are. He's hiding over there. The Sunderland Library does not take a position pro or con regarding fracking. That's not our role. Our role is to provide you with information in the form of books, other materials, and also to bring in the most qualified and knowledgeable speakers within our reach. And we're doing that tonight with our two distinguished speakers. The Sunderland Energy Committee, on the other hand, is a political body and does take a position on fracking. The library is here to help you make an informed decision on the matter, and I think by the end of tonight we'll know a lot more about what the stakes are, what the impacts are, what the geological realities are. Let me step back a little bit and just tell you about how this program came about. For those of you who don't know, hydraulic fracturing, or fracking as it's called, is a means of extracting natural gas, principally methane, and sometimes oil from shale deposits. It uses water, a lot of water, mixed with sand and various other chemicals, lubricants, solvents, corrosion inhibitors, under very high pressure to crack or fracture that shale layer and liberate the gas, which comes bubbling up through the well bore. This gas is eventually transported by pipeline or perhaps liquefied. Now, fracking, as it's called, is actually not a new technology. It's been around since the late 1940s. But what is relatively new is the combination of this technique with horizontal drilling. And that is exactly what it sounds like. They drill down to the shale layer, and then the drill bit takes a right angle and goes sideways, thus maximizing the surface area and contact that the wellbore has with the shale, which is relatively thin, but in many cases very broad. So that's when fracking became economically lucrative, because for a given well, much more gas could be extracted. Now, about a year ago, the U.S. Geological Survey identified a shale formation known as the Hartford Basin that extends from the bottom of Connecticut all the way up through the Pioneer Valley, we're sitting in it right now, along the Connecticut River, more or less, extending nearly to the Vermont border. And an organization with ties to energy industries called the American Groundwater Trust held a conference last December and expressed their opinion that fracking might come to the valley. And such remarks sent a ripple of alarm through the activist circles here in the valley. So as a library and also as an energy committee, we wanted to step back and ask some crucial questions. Just what is shale gas and how is it formed? Does all shale yield gas or only some types of shale formed under certain conditions? What type of shale do we have here? And what are the environmental impacts of hydraulic fracturing should it occur? What is the legal situation? What laws do we have on the books? What laws might we want to create on the books to govern this process or perhaps prohibit it? In order to answer these questions, as I said, we've brought in two of our most knowledgeable experts in the area. Our first speaker will be Dr. Stephen Petch, who is an associate professor of geosciences here at UMass Amherst. His research focuses on the processes that occur after the deposition of organic matter in sediment, and his research interests include anaerobic biodegradation of shale and coal organic matter associated with methanogenesis, creation of methane, and the delivery of rock-derived fossil organic matter to Earth's surface reservoirs, such as soils, rivers, and sediment. Two topics obviously germane to the present discussion. So I'm sure Dr. Fish will answer all your questions. We're going to have each speaker talk for roughly 30, 35, 40 minutes, and then we'll open the floor to questions and discussion after that. So please hold your questions until the end. And it's my great pleasure to introduce and welcome Dr. Stephen Petch.
I hope that you can see this. This is perhaps a little bit smaller than I was intending when I put all this together. As Aaron said, I'm a geologist. I've spent my career looking at organic matter and geological materials in a variety of different environments, including, to some extent, shale gas deposits. And that's part of why I was pleased to take the opportunity to talk to you today. The other reason I was pleased is because it allows me to do something I love to do, and that is have a captive audience held here so I can tell you something exciting about our local geology, because it's a really fascinating geology to be part of. So I have a bit of an outline for you. I'm going to go through the geology of shale gas. What are the requirements for producing a shale that can yield natural gas? What are the considerations that go into gas exploration and production? I'll end that with what is the ideal target from the gas industry perspective. From there, I'm going to turn to here, Western Massachusetts, and our Connecticut River Valley, and give you a description of what is our regional geology and our geologic history over the last several 100 million years, which is the blink of an eye for most geologists. And I'm going to put our local geologic context into the place of what is ideal for natural gas generation from an industry perspective. And you can then make your own comparison and contrast. Aaron had also asked me to do a little bit of talking about these industry practices, and you give a really great introduction. I may not have too much more sophisticated to say, but I do have some nice visuals to add to it, including horizontal drilling and hydrofracking. And lastly, I'm going to end with some statements about this shale gas assessment and some misunderstanding about what this gas assessment report really meant for those who are in the field and have a way of figuring out how to read it. So let me start with shale. What is shale? Shale is a fine-grained sedimentary rock. It's deposited in layers, it's abundant in minerals like quartz, flat platy minerals like clays. And as it's laid down, those flat platy minerals create a material that is really impermeable, meaning it's very difficult for liquids to flow through it, and very low in porosity, which means there's just not a lot of open space to hold liquids or gas. Often shales tend to be laterally extensive, so when they're deposited in quiet settings like lakes or lagoons or out in the open ocean, they may be deposited across many, many tens to hundreds of square miles in area. They may contain organic matter, but not all shales do. The vast majority of shales don't contain organic matter, but a few select, for me, interesting as research target types of shales called black shales do. These may contain a few percent organic carbon by weight. That organic matter is never very abundant, but it may occur, and as we'll see, there are some examples of very thin, not particularly rich, organic matter-bearing black shales in the Hartford and Deerfield basins where we're existing. That organic matter derives from the remains of aquatic organisms that lived in that ancient ocean or lake. Those organisms go through their life cycle, they die, they settle to the lake bottom or the sea floor, they become incorporated into that sediment. And as more and more layers of sediment are deposited, those shale layers become deeply buried, and eventually that organic matter begins to break down. It's this breakdown of that ancient organic matter that generates our fossil fuel resource, either oil or gas. Some science. You can see this. What I have, I've pulled, and I've tried to reference where I've pulled all these figures from. This is just one that I found from the Department of Natural Resources in the state of Louisiana. That as you move downward into the interior of the Earth, the temperature and the pressure increases pretty gradually. It's not that you can dig a hole in your backyard and reach heat necessarily. But as you get down several hundred meters, several kilometers, temperatures and pressures will increase. At a temperature of around 60 degrees Celsius, somewhere probably in the order of 5 kilometers depth into the earth, the organic matter, if present in a shale, begins to break down, first forming oil, petroleum, and ultimately natural gas. We're kind of showing this here. Here's temperature, 60 degrees. Pink is the generation of oil and some amount of natural gas. As temperatures and pressures continue to increase with depth into the earth, that shale will continue to have its organic matter break down, generating more oil and gas. Ultimately, at temperatures of around 160 degrees, the oil itself is broken down, converting into natural gas. And then, as temperatures continue to increase with more burial, so deeper into the interior of the earth, those high temperatures change the mineralogy of the rock. They change the rock's capacity to hold gas, and the gas itself is driven off. And so by the time you reach temperatures of 200 degrees Celsius or so, that rock's really unlikely to contain much, if any, natural gas. What is natural gas? Well, natural gas is naturally occurring gaseous hydrocarbons such as methane, ethane, propane. These are all flammable. They react with oxygen to produce carbon dioxide and water, and that's why they're so useful as an energy resource. Although these gases are called gases, an important and perhaps unrealized point is that they do not actually occur freely in rocks. I cannot drill down, core down, mine down into the earth and pick up a piece of shale and find gases existing abundantly in the pore spaces of that rock. Those shales just do not contain sufficient open space. Instead, these hydrocarbons are actually adsorbed onto any residual organic matter in the rock itself. You can almost think of these gases as dissolving into the solids of the rock, into the solids of the organic matter of the rock. This presents a real challenge for extracting this gas because once dissolved, with high pressure present, it's very difficult to release that gas in any form. Another aspect to shale gas production is this concept that fluids in the subsurface freely migrate. We can have water migrating, we can have oil, if generated, migrating, and gases can slowly migrate through materials in the subsurface. But in shales and many sedimentary rocks, the low permeability, the capacity, how fast material can flow, and the low porosity, how much space there is to flow through, really limit the rate at which materials can move through the subsurface. It may be millimeters per 1,000 years, millimeters per hundreds of thousands of years. That's how fast these materials can move. As a geologist, I got time. And so, millimeter per 1,000 years, we can still move many meters in tens of millions of years. And so, when we look at oil and gas deposits around the world, we're seeing this migration that's not visible on a human timescale, but is certainly visible over geologic timescales. These gases and oils are buoyant relative to any water in the system. So in a petroleum system, the gas and the oil will float to the top of that oil. You think of like a good vinaigrette that you let to settle out and the oil floats over top of your vinegar. Those gases and oils will rise buoyantly, slowly, over geologic time until one of two things occur. You may have an architecture of the rocks in the subsurface that somehow trap that oil. That the oil or the gas rises until it hits something that is so impermeable that no further rise can actually happen. We would call that a trap rock or a cap rock or a seal. In other cases, and probably over geologic history, the vast majority of cases, that oil and gas migrates and ultimately escapes to the surface. It's very common to have naturally occurring gas seeps, oil seeps, and tar seeps in many locations around the world. Maybe the more famous is La Brea tar pits in Los Angeles. This is a naturally occurring hydrocarbon seep where hydrocarbons that are generated in the rocks at depth are rising upward, and there's nothing stopping them from escaping to the surface. One term, or one pair of terms that you may have seen if you've done any reading about the potential for resources, natural gas resources in this area, is a distinction between conventional and unconventional resources. Conventional resources are the targets that the oil and gas industry has used for decades. It's the easy stuff. It is pods and pockets of oil and gas that have risen to occur in traps in the subsurface. And so the oil industry will drill a well and think of that well as just a straw or a siphon, siphoning off material from one isolated pod or pocket. Now those pods or pockets are not hand-sized. They may be the size of this room, or more likely the size of a city block. But it's still a discrete geometrical region. Unconventional oil and gas resources don't follow this simple pod and pocket model. In these kind of resources, the gas has never migrated sufficiently, or if it has migrated and escaped, and whatever remaining residual oil or gas in the system is distributed and dispersed at low concentrations throughout the rock formation. Shale gas deposits are unconventional resources. There's not a concentrated pod or pocket, but instead it's distributed at very dilute concentrations throughout the system. Shale gas is natural gas that is contained in the same rock formation from which it formed. So instead of having migrated out of the rock, it represents whatever amount of residual natural gas is still retained in that low permeability, low porosity rock. Because the natural gas is readily absorbed onto the rock where it's generated, this hinders its capacity to migrate. And for much of the history of the oil and gas industry, these kinds of rocks were not recognized as targets for resource extraction because we did not have technology that allowed that gas to be extracted. However, petroleum geologists recognize that because of the amount of organic matter in those rocks, and this organic matter that can so readily absorb and dissolve natural gas, there could be vast amounts of gas, hundreds of cubic feet of methane in an average ton of black shale. But there's no ready way to extract this until some of the recent technological advances that Aaron had talked about. Shale gas is also not an uncommon type of resource in our country. This is a map from the US Energy Information Administration. I was lucky to find it archived because, as you might imagine these days, the EIA.gov website, like everything else down there, is shut down, so I can't actually access this stuff. But luckily I had an archive of this that I could pull out. And what this map is showing you is various plays, which is an industry term for a place where natural gas is being extracted. Various plays around North America, the United States, Canada, to some extent into Mexico. The one that you probably have heard about that's closest to us is the Marcellus Shale in Pennsylvania and New York. Note that there is no shale play listed on this map. The US EIA does not recognize our region as an existing play, meaning there is currently no resource extraction anywhere in the Hartford Basin. Some other terms you may have come across when you've read about shale gas is that it's categorized as a continuous gas type of assessment unit. An assessment unit is just a geologist's way of assessing how this resource exists in the subsurface. We call it a continuous gas type of assessment unit for two reasons. One, we call it a gas assessment unit because it's gas, not oil. And it's continuous, not meaning to imply that the gas could be continually produced, but rather that the gas is spread throughout the region and not localized in particular seams or pockets or pods in the subsurface. You also may see shale gas described as a composite petroleum system. I had to do a little bit of homework on my own to figure out exactly what a composite petroleum system means. And it kind of means that It's either too difficult to determine or too little information exists to get a real sense on how that petroleum system, if it exists, would work. A petroleum system is a systems approach that recognizing that there's sources of oil and gas, and then there's migration pathways, and there's reservoirs and caps that make the whole system. A composite system is, we don't really know enough to characterize what a petroleum system is. So it's sort of a word to hide. Let me summarize this for you. The ideal geology for a continuous natural gas play would include thick beds of shale, tens to hundreds of feet thick. Laterally extensive, that occupies many hundreds of square miles in the subsurface. Limited thermal maturity so that the gas remains in that shale, that we've not gone past the oil window, past the gas window, and essentially overheated the rock so that the gas had been driven off. And a subsurface architecture, so the sort of the arrangement of the blocks of rock in the subsurface that makes a coherent whole instead of a subsurface that is broken up and fractured into small pieces. And just as an example of this, this is a photograph that I found to show you of an incoherent subsurface architecture. This is some rocks that are exposed along the Severn Estuary in Somerset in the UK. And I hope your eye, this is my Intro Geology 101 hat for a moment, that you can see that these layers in this reddish colored rock are truncated right along this feature, and on the other side are different colored rocks. What has happened there is faulting occurred. And this whole block of rock at some point in its history was much, much higher and dropped down and towards the left. And it's not simply one fault surface, but if you look carefully, there's actually multiple fault surfaces across this. This rock is completely broken up as a result of tectonic processes. This becomes important when we talk about our valley here. So I want to turn to the geology of Western Massachusetts. This is a fact sheet that our state geologist office has available on their website. They also have print copies for you. And it's just a very crude overview of the bedrock geology of Massachusetts. What I want to draw your eye to here in this oval is in the Berkshires and in central Massachusetts, we have crystalline rocks, igneous and metamorphic rocks. These are not rocks that contain organic matter. These are not rocks that are in any way possibly a source or target for oil and gas drilling. But we do have, running right up here through the Connecticut River Valley, a region of sedimentary rocks. Kind of blown up here, this is a topographic rastered image of our region here in Massachusetts. I have not put any of the towns on it, unfortunately, but here you can see the Holyoke Range, the Potomac Range, so we're sitting right about here. Amherst is right about here. That this swath of sedimentary rocks in western Massachusetts extends from the Connecticut-Mass border all the way up to Northfield. The region that is sedimentary rocks is about 10, 15 miles wide around Springfield. And then north of the Holyoke Range, it narrows to only about 3 or 4 miles wide, right where we're sitting here in Sunderland. Geologists call the northern portion of this swath the Deerfield Basin because it was a basin of topography that filled with sediments deep in the geologic past. And south of the Holyoke Range, we call it the Hartford Basin. This Hartford Basin extends into Connecticut. And as Aaron was saying, this Hartford Basin here, we can see, here's the Mass-Connecticut line. So we're here in Sunderland. This Hartford Basin extends all the way down to New Haven. This basin is just one of, probably 12.5 of these sedimentary basins that formed about 200 million years ago. And I'll get a bit more into the geologic history of these, but we're by no means the largest, the most extensive, for a geologist or an economic geologist, the most important of these basins to consider. The rocks in the sedimentary rocks in our Hartford and Deerfield Basin include sedimentary rocks such as sandstones, conglomerate, and some shales. The region also includes several basalts, which is an igneous rock, and I'll turn to why that is an important trigger in just a second. Let's go through this geology. So what I have here is a blow-up Geologic map. Here's Amherst, here's the Connecticut River, here's the Pocumtuck Ridge, Deerfield, and we're sitting right about here. In white is the western half of the basin that is made of a rock called the Sugarloaf Arkose. Before the sunset, we've had a great example of the Sugarloaf Arkose right here in Sugarloaf. That's why it's called the Sugarloaf Arkose. It's named for that site. The Sugarloaf Arkose is that reddish-colored, kind of coarse, sand-sized material that contains no organic matter, no potential for generating oil or gas. And one lesson you can get out of that is well over half of our Deerfield Basin is Sugarloaf Arkose. In no way possibly a potential for natural gas generation. Just to the east of the Sugarloaf Arkose is a 300-foot thick layer of basalt. Locally we call it trap rock. Sometimes it's called diabase. It's called the Deerfield basalt. It's an igneous rock. It's not sedimentary. It was deposited as molten lava from one or more likely more volcanic eruptions deep in the geologic past. So who knew that we had volcanoes in Massachusetts? Well, we did. It's just they were 200 million years ago. It forms the ridge that runs north from Sugarloaf up towards Deerfield. And as an igneous rock, as a former lava, it contains no organic matter, no oil, no gas. The far eastern part of our Deerfield Basin is made of a rock called the Mount Toby conglomerate, named for its type location at Mount Toby. Conglomerate is a sedimentary rock that contains large pieces. Think of this was deposited in a river channel deep in the ancient past. So it's a mountain stream that became a sedimentary rock. You can see in this photograph, there's pieces of cobble, gravel. It also contains no organic matter, no gas or oil. And that occupies, here it's with the circles in this map, a large portion of the real estate of our Connecticut Valley. And so what's left? Well, between that basalt and the Mount Toby conglomerate is a rock formation called the Turner's Falls Formation. The Turner's Falls Formation is several hundred, I'm trying to remember exactly, maybe 2,400 feet thick. And it contains interbedded sandstones, siltstones, and some shales. Some of those shales, but not all, contain a small amount of organic matter. The cumulative thickness of those shales, not breaking out the organic matter rich and the organic matter absent ones, is probably less than 50 feet thick, and individual beds are inches to maybe a foot or so thick. These are very thin beds of shale. This is a photograph I took back in August. I had some students out on the Connecticut River. This is from the rail trail bridge at Greenfield Montague, looking out of the bridge. You can see a little bit of the chain link fencing from the bridge here. This is the Turner's Falls Formation. You can see it exposed when the river is at low stage on the Connecticut River. It's a small but not insignificant region of our Connecticut Valley. Now, because we don't want to ignore the rest of the state and the rest of the Hartford Basin, the rest of the whole region, the rocks of the Hartford Basin from the Holyoke Range south are similar to the Deerfield Basin in their age and their geologic origin. I'm not going to go into a great amount of detail of these. That's the land area around Springfield south all the way through to New Haven. This sequence of rocks in the Hartford Basin is thicker than what we have in the Deerfield, has more examples of these basaltic lava flows, and there are more formations that contain thin beds of shale. These shale beds in the Hartford Basin are thin, and they're not laterally continuous. You might have what was a small ephemeral lake where shale deposited, and that lake may have only been a few hundred feet across at the time of its formation. And so these beds don't extend over large amounts of real estate. This is a photograph I obtained. This is on Route 9 in Connecticut around Middletown, looking at some of the rocks in the Hartford Basins. We don't have great road cut exposures of the equivalent Turner's Falls for us, so I can't show you a photograph. This gives you some idea. Here is some Arkose, some various sandstones, and then this black layer here is the East Berlin Formation in Connecticut. It's one of the black shale layers. This is about the thickest these shales get, and if I use the light pole and the guardrail for scale, it might be this thick. So it's not a thick, extensive bed of shale to be concerned about. Another aspect to the geology of our Connecticut River Valley is what was going on at the time of deposition. So if we take you back in time, 200 million years ago, North America and Africa were connected as one continent, and about 200 million years ago, tectonic forces were pulling these apart. There was extension of Earth's crust. And as that extension occurred, it generated faulting in the system where blocks of Earth's crust dropped down relative to each other. I'm kind of showing you that on this cross section. If we look here, this would be from the west to the east, right around this region. Off to the west, we have the Berkshire Hills. To the east, we have the Pelham Hills, hills around Pelham, Shutesbury, New Salem. And then we have in our basin, and coeval with the formation of our basin, this sequence of sedimentary rocks. The oldest would have formed when this fault was fairly small, and that would be our Sugarloaf Arkose. Then, with a little more faulting, we had some of that volcanic activity leading to these volcanic eruptions and the flood basalts. With a little further faulting, we had the Turner's Falls Formation and the Mount Toby conglomerate being deposited. What's critical about this is the dropping down of that basin occurred at the same time it was filling up. You know, Earth doesn't make a hole without filling it up pretty immediately with eroded sediment. And so faulting and fracturing of the entire sequence occurred throughout its depositional history. This is really important because it means that, and I've kind of designated, there's one major fault to the east that kind of cuts underneath our very feet here, but then throughout there are small minor faults and fractures throughout the whole sequence that it is pretty near impossible to find an example of any of the sedimentary rocks in our basin that are not fractured apart. Allow me 2 gratuitous slides, because I actually love these sorts of things. This is from a colleague of mine down in Texas, and it's paleogeography. So this is a map of the world 237 million years ago. Here's North America. We're here in Massachusetts, where there was a massive mountain range, and we're glued together with Africa and South America. And then roll our tape forward a few tens of millions of years to 195 million years ago, and the very first gasp of the Atlantic Ocean is starting to form. That's why we have our basin here, that we're part of that rifting and spreading apart of the continents. You know, I teach Geology 101. This stuff's really kind of fun to think about, you know, continents moving around on Earth's surface. There's another aspect of the geology that's important for you, and that has to do with the thermal maturity. How hot did our rocks get during their history? There's been a few, but very few, studies of the maturity of the organic matter of the rocks in the Hartford Basin. Other than a small region in green down here just to the northeast of New Haven, these rocks are all highly thermally mature, which means that during their burial they were subjected to temperatures greater than 200 degrees. That is well past the oil window. If it's at the tail of the gas window, and likely any gas that was generated, and we know that oil and gas had been generated at some points in the history of these. It was generated, you know, so if you wanted to be an investor in the gas industry in Western Massachusetts, you're 180 million years too late. We produced it, but it largely escaped out to the surface. Due to the extensive faulting and fracturing that has broken up this rock, oil migrated out of the rock. There was no cap or no seal. The oil escaped to the surface as a natural set of oil seeps. Natural gas slowly escaped to the surface. The intense heat drove off most of the gas, and very little of it was able to be retained in the rock. There's one study that extended work in the Hartford Basin up to our region here in the Deerfield. And this study, it was from a now retired geologist from my home department at UMass. And he looked more broadly at the Hartford Basin and has 2 samples from up here in the Deerfield, and we're all over mature. Or the rocks are, I'm not talking about any of us. But the rocks are all over mature, that if they generated natural gas, it's at the very tail end. We've heated up that rock, that its capacity for absorbing and retaining and storing natural gas is extremely limited. So let me summarize this side of the geology. I described to you what's the ideal natural gas site and what's our reality. We fall short of being ideal targets. Our shale beds are thin, they're laterally discontinuous. They don't extend over tens to hundreds of square miles. They're not laterally extensive. The shales are thermally mature, if not over-mature, and they're highly fractured and faulted, unable to be good targets for placing a drill bit. All right. And Aaron had also asked me to do a little bit on horizontal drilling and hydrofracking, and he gave actually a really nice introduction. There's not too much that I can say about it. I will say I find the idea of this technology somewhat fascinating. When I first learned about horizontal drilling, I have a drill bit at home, and I can't drill around corners with it. And so the idea that we have technologies that can do this in the subsurface, there's a certain amount of fascination to that. What is done in horizontal drilling is it provides a means of drilling a well that doesn't have to follow a straight line, but that can make one or more turns. The drill bit actually can be steered at the very end of drilling. And this would allow an operator to stay within a particular formation. It's not exactly possible yet to know the location of a drill bit in the subsurface. It's done by somewhat educated guesses. And one result of this is that horizontal drilling that is attempting to stay in one formation needs to have a fair amount of leeway. It's not possible to drill through a thin formation and know that you've stayed within it. Operators need very thick shales to be drilling horizontally through because their precision is not accurate enough to know that they've actually stayed in that area. After drilling is completed, cement is pumped into the well to seal it. There's a casing that is laid down, usually a metal sleeve that is designed to keep the interior of the well separated from what surrounds it. And then cement is pumped to further that seal between the interior of the well and the rock that surrounds it. The hydrofracking part of this is also called hydraulic fracturing. It's a method used to enhance gas or oil production by making many small and localized, just in a few meters around the bore of a well, small and localized fractures. It enhances the permeability and allows water and gas to more readily flow into the well. How this is done is after a horizontal well is drilled, casing is in place, cement is all sealed, then a detonating gun actually ignited deep in the subsurface, creating small fractures in that casing, that cement, and extending out into the rock surrounding the well. Following that, at high pressure, a mixture of water, sand, and various chemicals are pumped into the subsurface. These chemicals, this fluid is used, the high pressure is used to dilate those fractures that were created. The sand is in place as a proppant to keep those fractures from collapsing on themselves once the pressure is released. The water is used to carry the material, and then the chemicals. The additives in fracking are just a small percentage of the total, but they are worth knowing about. They include acids that are used to help dissolve some of the minerals in the rock. There's lubricants to make the sand slide better. There's inhibitors for scale so that you don't form scale in your wellbore and clog the pipe. There's buffers to maintain the pH and the viscosity of the liquid. And there's biocides to prevent any organisms from growing in the system. We have information about what these are, and this is probably something Peter, our next speaker, is going to be talking about. Some of these additives are harmless, others are dangerous, toxic, carcinogenic. I'm not an expert on this side of things, and I don't want to go out on a limb talking about it. I can point you to some resources if you're interested in reading about it. I think I'm not going to go further about the fluids in fracking there. Where I want to end is the production side, is after fracking, a strong vacuum is placed at the top of the well to draw out water and fluid. This vacuum draws up gas, formation water, and at least initially some of that fracking fluid. On the surface, you have this methane, water, hydrofracking fluid mixture that goes to a separator facility where it's essentially just dissolving or exsolving the gas out of the water. The gas goes into some sort of pumped pipeline, and then this is my hedge. Disposal of the water varies. And I'm sure you may have means to address this. Sometimes it is reused, sometimes it is disposed of in the subsurface, sometimes it is stored on the surface. Again, I'm not prepared to go into more details of that. I want to focus on the geology for you. The last little bit that I want to talk about is this USGS report that may have caused some concern. So back in December of last year, there was a Boston Globe paper, Western Mass viewed as territory for fracking, which probably raised alarm for some people. The basis of this article came from the conference that was held at, unfortunately, UMass, from an industry group, as well as this USGS report, which is Assessment of Undiscovered Oil and Gas Resources of the East Coast Mesozoic Basins of the Piedmont, Blue Ridge, Thrust Belt, Atlantic Coastal Plain, and New England, 2011. Let's translate that. Mesozoic basins, we're talking about the same kind of basins we were mentioning when we talked about the Deerfield and the Hartford Basin. These places where sediments accumulated during the Mesozoic, roughly 200 million years ago. Undiscovered oil and gas. We don't know if there's gas, and by this, the author means we don't know if there's oil and gas. There's just a geological reasonableness to start investigating it. In that USGS report, it was a 2-page fact sheet, reviewed the potential for natural gas resources in several unassessed regions along the eastern coast of the United States. There was a map in the report shown here that shows 14 basins where there's a geologically reasonable possibility for natural gas. Starting from here in Florida, continuing all the way up to us here in the Hartford Basin. One thing you can get out of this map is a sense of scale that we're not a particularly large basin as things go. The other thing you should get out of it is we're one of the orange basins, not one of the red basins. This report only assessed in a formal sense, given a unit that told you amount of possible gas. It assessed that resource for 5 of these 14 basins, and we were not one of them. The Hartford-Deerfield Basin was not one of these assessed basins. They are undiscovered in the sense that there's a geological possibility that given the sedimentary history, there may have been appropriate conditions for generation of oil and gas, but it's not known to contain or produce any existing fossil fuel resource. So, given what I told you about our geology, it is reasonable that we have shales, we have a little bit of organic matter, the stuff was heated up. There's evidence that it generated oil and gas 180 million years ago. But it's not going to be assessed in a formal sense because it does not make a good target. It doesn't make a good target for the exploration production side from the industry, but even further, it's not a good target for further study to even see if it could be a good industry target because it's just too unlikely given our geology. So, what do we do? Well, I gave you some idea what's the ideal geology for a shale gas resource. And I hope you have some understanding. We want extensive, thick beds of shale, a little bit of thermal maturity, but not too much, and a subsurface architecture that's not all broken up. Instead, here we have a few thin shales, not laterally extensive, intense thermal maturation that drove off much, if any, of the natural gas that might have been produced, and extensive cut up, broken up subsurface architecture that doesn't make good targets for drilling. There's a sophisticated technology involved in that exploration and production, horizontal drilling and hydrofracking, but it's not likely this could be applied here because we don't have the right kind of geologic targets for it. And just to be aware, there has not been any assessment of Western Massachusetts as a potential natural gas resource. And given our regional geologic setting, this assessment is highly unlikely to ever occur. All right, thank you very much.
Thank you very much, Dr. Pesch, for that enlightening and very erudite summary of the geological history of our region with respect to shale and other formations. Our next speaker is Peter Vickery. He's an attorney in Amherst. As you will hear, he was educated at Oxford University, Western England, University of Western England. He also attended BU Law School and here at UMass Center for Public Policy and Administration. He has been practicing law in Amherst since 1999. His specialties are employment, discrimination, and trademark law. He's a former member of the Governor's Council for Western Mass, serves on the State Ballot Commission, and he's also a specialist and has a deep interest in environmental law, is an active member of the Sierra Club. And for all these reasons, I asked him to talk about the ecological implications of hydraulic fracturing, and especially the legal situation here in Western Mass. What laws do we have on the books? What laws might we want on the books? And given what Dr. Pesch has just outlined for us, what's the best course of action? So without further ado, Peter Vickering.
Thank you. Well, thank you, Aaron, and thank you, Stephen. That was a wonderful presentation. And thank you, Public Library and Energy Committee, and you all for being here this evening. I'm Peter Vickery, I'm an attorney, and what I'm going to talk about is the legal landscape for fracking in Western Massachusetts. And what I have to say only becomes relevant if all those three highly unlikely contingencies you just heard about happen to align. So the first unlikely contingency, that someone actually explores for shale gas in Massachusetts. Second highly unlikely contingency, that they find some. And the third unlikely contingency, that someone decides to try to extract that shale gas. So those three things, in a sense, I have to ask you to suspend your disbelief and pretend that what I'm about to say is relevant. It's just like being home with my three kids. Pretend what I'm going to say is relevant. So if those three things were ever to come to pass, what would the legal landscape be? Would somebody legally be able to extract shale gas in Massachusetts? So I'll be focusing on four different things, four legal items: a regulation, a statute, and two provisions of state constitution. So the regulation is 310 CMR. CMR stands for Code of Massachusetts Regulations. 310 CMR 27.041. That is the regulatory ban on Class 2 wells, which I'll get to in a little while. The second item is the statute that authorizes that regulation. And those two constitutional provisions are Article 10 of our state constitution, which talks about the government not being able to take your property without paying you just compensation. So that's the takings provision. Government can't take your property without paying you. And the other article is Article 30, and that's the article that says, part of our state constitution, that says the legislature cannot delegate its lawmaking authority. So you know we have a separation of powers, judiciary judges, the executive executes the laws, the legislature legislates. Everybody has a job to do. The legislature's job is to legislate. It cannot slap that off, farm it out to somebody else. So what I'll be talking about is how these four different items fit together, or not, in the event of somebody challenging that regulation. So the first thing I'll talk about is the regulation that bans Class 2 wells, which I'll explain in a moment, and how it fits together with the statute, and how the statute and the regulation fit into the constitutional puzzle, how they fit together with Article 10 and Article 30. And this only becomes relevant if all those three things happen and somebody tries to drill and they confront this ban on Class 2 wells. And why are we even talking about this at all? Because of the remote possibility of hydraulic fracturing, the process that goes on not in Massachusetts, but goes on in other parts of the United States, like Pennsylvania. That's a frac rig. That's a part of the world that looks a little like here on the surface, but clearly underground is not a lot like here. So that's not Massachusetts, but that is a frac rig. There's no fracking in Massachusetts but there is plenty of fracking for Massachusetts. And the reason for that is the vast majority of the electricity we use in Massachusetts comes from natural gas. Not much of it comes from coal anymore. Most of the electricity we used to come from coal. Some of it comes from nuclear, some of it comes from renewable energy. But in 2011, the most recent information I could find from the EIA, the Energy Information Administration, part of the federal government, their most recent estimate for electricity generation in Massachusetts was that 68% of the electricity we use here, the reason the lights are on, the reason this is working, is because of natural gas. 68%. That natural gas comes from Canada, it comes from different parts of the United States, none of it comes from Massachusetts, but we import natural gas from different states and from Canada. It ends up here, and because of it, we can turn the lights on. So no fracking in Massachusetts, but plenty of fracking for Massachusetts. So here's the first legal item. Professor Petsch described the actual landscape. This is the first feature on the legal landscape. And this is 310 CMR 27.041, and it became a regulation in Massachusetts back in 1982, and it says, no person shall inject fluids into or through an injection well, and no person shall construct, install, operate, or maintain any class 1, 2, or 3 injection well, except as authorized by this regulation. Why do we care about injection wells? That's the only way you can extract natural gas through hydraulic fracturing. If you want to engage in hydraulic fracturing, what you need is a class 2 well. It's a form of underground injection. And this regulation from the Department of Environmental Protection says no class 2 wells. So thank you, you've been a wonderful audience. Good night. No, a regulation banning something to an attorney is a red rag to a bull. So it's not, in any sense, the end of the story. The regulation banning class 2 underground injection wells is not where the story ends, it kind of starts. The question becomes, what if that were to fade away? How robust or vulnerable is this regulation? Could the regulation withstand a challenge? So, if those 3 contingencies happened, and somebody tried to create a class 2 underground injection well and extract natural gas from Massachusetts, and they came up against that regulatory ban, and they went to court, they did the American thing and sued, would that regulation be able to withstand a challenge? So that's the question I'd like to explore briefly. A quick reminder of how these things all fit together. At the top, this is a hierarchy of legal authorities. At the top is the Constitution. I'm just looking at Massachusetts now. The Constitution of the Commonwealth of Massachusetts at the top. At the bottom are regulations. So a state agency, an executive agency like the Department of Environmental Protection can only promulgate or create a regulation if the legislature has authorized it to do so by way of a statute. So next layer up is a statute. Regulations are kind of the anthills, statutes are foothills, and the mountains, that's the Constitution. That's the peak. So the Constitution says what the legislature can and cannot do, and it's the statutes that say what a state agency like the Department of Environmental Protection can or cannot do. Bear that in mind. An aside. Doesn't the Federal Safe Drinking Water Act make this a federal question? Why are we even talking about state law? Some of you will have heard of the so-called Halliburton exemption in the Federal Safe Drinking Water Act. The Federal Safe Drinking Water Act authorized the federal equivalent of our Department of Environmental Protection, called the Environmental Protection Agency, to create something called the Underground Injection Control Program. And the Underground Injection Control Program does not regulate hydraulic fracturing for the purposes of natural gas extraction. Why not? Because Congress said it cannot. So you'd think that this process for using underground injection to extract hydrocarbons would be subject to the Safe Drinking Water Act. It's not. Congress exempted it, so this isn't under the Federal Safe Drinking Water Act for one reason. There's another reason that state law applies with one important exception. There's a reason why state law applies here, not federal law. And the reason is we have primacy. So the underground injection control program that the federal government created has a provision that allows states to run the program themselves, to obtain primacy and run the program instead of the feds. So the Federal Safe Drinking Water Act Part C says states can have primacy over this program if they meet certain standards, if they jump through certain hoops. And Massachusetts jumped through those hoops. In August 1982, there was a memorandum of agreement between the Commonwealth of Massachusetts and EPA Region 1. And as a result of that contract between the federal government and state government, they contracted, and as a result, Massachusetts has primacy over the underground injection control program, with one important exception. So what the Attorney General wrote, he had to write an opinion saying that our state regulations were at least as stringent as the federal regulations in order for the feds to give us primacy. And what the Attorney General wrote back in 1982 was that that regulation I just showed you, the regulation prohibits the construction, installation, or maintenance of any class 1, 2, 3, or 4 injection wells. So that is the opinion of state government in 1982. And that's the stance of state government today, that that regulation prohibits class 2 wells, the kind you need in order to engage in fracking. Thank you, me, for reminding me, remember to mention the important exception. And I will, I promise you, but not quite yet. So this was 1982, and I say not that long ago, in my opinion. That's when, remember the DeLorean? 1982 is when the DeLorean Motor Company stopped production. To me, 1982, the 80s seems like last week. According to my independent panel of experts at home, the 1980s was a long, long time ago. And Father, you're a sad old man for suggesting otherwise. So the three children say the 80s was a long time ago. Audience participation. Who was president in 1982? Reagan, yes, excellent. You don't get any points for that, but yes, President Ronald Reagan was in the White House in 1982. You might get a point for recalling who was governor of the Commonwealth of Massachusetts in 1982. How quickly we figure out. Right. So 1982 was a long time ago. Say my children. Bonus points for guessing or remembering who was the Attorney General of Massachusetts in 1982. Nope. Good guess, though. Anyone else? You'll kick yourselves. Name that's on the tip of everybody's tongue. Francis Bellotti was Attorney General. So I mentioned this not to show you up for not having a perfect recall of Massachusetts politics in the 1980s, but to make the point that it was a long time ago. And this is important in the event of a courtroom challenge. Because something else was real in 1982. Absence of any widespread hydraulic fracturing for natural gas. So when Massachusetts entered into this compact with the EPA, no hydraulic fracturing for natural gas. Important to remember. So the regulation bans class 2 wells. What authorized the DEP to ban class 2 wells? This statute. And this is where somebody challenging that statute, that regulation, would start to have fun. So an agency can only promulgate a regulation if the legislature says it can, and here's the piece of legislation that authorized the DEP, the state agency, to enact that regulation. It says that the DEP can take all action necessary or appropriate to secure to the Commonwealth the benefits of the Federal Water Pollution Control Act, as amended, and other federal legislation pertaining to water pollution control. So at this point, you might think I could say, well, thank you very much, good night, because here's the statute that authorizes that regulation. But there's a problem with it, and it has to do with action necessary or appropriate. All action necessary or appropriate. I'll come back to that problem in a moment. But this is the statute that clearly authorizes the DEP to regulate underground injection wells. So regulate is one thing. Banning is something altogether different. So the question that an attorney for an energy company would put to the Supreme Judicial Court would be, did the legislature intend that the agency should go ahead and ban Class 2 wells? Is that what it meant in 1982? When it said to the DEP, go forth and regulate underground injection wells. Is that the same as ban them? Probably not. That's not what we mean by, what did they say? Action necessary, appropriate to secure the benefits of federal legislation pertaining to water pollution control. Back in 1982, did the feds ban fracking? No, the feds hadn't banned hydraulic fracturing. So that's probably not what the legislature had in mind. When the legislature said to the Department of Environmental Protection, enact a regulation to regulate Class 2 wells. That's not the same as saying go forth and ban them. So that's one question that the attorney for the power company, for the energy company, would ask and answer. And even if the legislature had said that, did the legislature have the constitutional authority to let the agency decide whether to ban Class 2 wells? So this is where Article 10 and 30 start to come into the conversation. Non-delegation, Article 30. The executive shall never exercise... I'm just going to grab my water. The executive shall never exercise the legislative and judicial powers of either of them. Or either of them, as we Americans say. The executive shall never exercise the legislative and judicial powers or either of them. At the federal level, you know, we've got the separation of powers, and it's not just implicit, it's really there in the Constitution. The vesting clauses of the three main articles of the Constitution, all legislative power shall vest in the Congress, all executive power shall vest in the President, all judicial power shall vest in the Supreme Court and such courts as it shall create. So the separation of powers is real at the federal level, it's very real at the state level, and our state constitution makes abundantly clear that the executive, and that includes the Department of Environmental Protection, shall never exercise legislative powers. It can do its own job, it has to do its own job, it cannot give that job to somebody else. Now, why? And who's this? Who is it? It's the guy from The Office. It's
Steve Carell.
Yes, Steve Carell playing Michael Scott from The Office, who is just the most useless boss, okay? This is the kind of boss who just wants to be popular. He never really does his own job. He's always kind of shucking off his responsibilities to his co-workers and doesn't take responsibility himself. He would much rather just take off and be at the bar or just having fun. That's what our Constitution wants the legislature to not be like. Our Constitution doesn't want our legislature to be that kind of character. It doesn't want it shucking off its responsibilities to another branch of government. So the legislature must not be like Michael Scott. The legislature legislates. The legislature cannot say to an executive agency, you go ahead and do the legislating for me. How do we know when a state agency is exercising the lawmaking power? So this is the constitutional argument that an energy company attorney would make. The energy company attorney would say that the regulation goes beyond what the legislature had the power to authorize the executive agency to do. And the first way that the court would look at this, the first question it would ask would be, when the legislature enacted that statute I just showed you, the one that authorized the DEP to issue the regulation, did the legislature delegate the making of fundamental policy decisions rather than just the implementation of legislatively determined policy? That's really the biggest question, is did the legislature farm out to an executive agency the responsibility of making a fundamental policy decision? First question. The second one is, does the Act provide adequate direction for implementation? Did the legislature tell the DEP, here's the guidance, here's how we want you to regulate underground injection wells, like Class 2 wells. And the third question is, does the Act provide safeguards such that abuses of discretion can be controlled? So does the Act say the DEP can only go so far? It can only regulate wells reasonably. It can regulate wells within these parameters. It can't go ban them. And there's another question. Are there fundamental due process principles implicated? But let me go back to the first question, because this is the important one. Did the legislature delegate the making of fundamental policy decisions rather than just working out the details? And the case, for anyone who's interested, whether the court most recently looked at this issue of non-delegation, this doctrine of non-delegation, it's called Commonwealth v. Clemmy in 2006. That's when the Supreme Judicial Court sort of did a survey of all the relevant cases and said, we've looked at all the cases to do with non-delegation. And here are the 4 questions we've come up with. This is what the courts usually ask when we're trying to analyze this kind of question. This isn't a 3-pronged test, but this is sort of the area, this is the zone you need to be in. You need to be asking about fundamental policy questions. So I think they probably win on that. I think the energy company attorneys would be able to make a very strong case that when the DEP enacted the regulation, it really was making a fundamental policy decision. There's another constitutional question, but just bear in mind, this is the issue that I think it would hinge on, whether the legislature said, DEP go forth and work on the details, or whether the legislature said, you go make the policy decision. We're going to be like Michael Scott. We just want to be popular. We don't want any mean things said about us. You take all the flak. So that's the big question. So the second, and I'll end shortly, the second constitutional provision that's at play is the takings clause. So those of you familiar with this area of law at the federal level know that the Fifth Amendment has a takings clause. Here in Massachusetts, our Constitution has something similar. Article 10 says, no part of the property of any individual can, with justice, be taken from him or applied to public uses without his own consent or that of the representative body of the people, meaning the great and general court. Why would this be relevant? Let's say that those 3 things happened. Those 3 remote contingencies did in fact come to pass. And some farmer in a little further north from here found that there was natural gas under his land, or her land, and wanted to enter into a licensing agreement with a company that would drill and extract that natural gas, confronted this ban, this regulatory ban, and said to the judge, this regulatory ban amounts to a taking. The question is then, can a regulation be a taking? And he said yes. Our own Oliver Wendell Holmes Jr. used to be a Massachusetts guy. He was on the Supreme Judicial Court here in Massachusetts, then was elevated to the Supreme Court of the United States. Oliver Wendell Holmes Jr., Civil War veteran, great guy, hero. But he said in this important case, Pennsylvania Coal v. Mahone, in 1922, almost 100 years ago, but in that case he made 2 important points. He wrote the decision for the court, and he said that sometimes regulation goes too far. Sometimes regulation can be a taking. And the other thing he said that's relevant to this kind of situation, this unlikely but remotely possible event, is that the right to coal, because it was a coal case, the right to coal consists in the right to mine it. So if the farmer went to court and the state government said, we're not taking your natural gas from you, this regulation doesn't take it from you, you still have the right to look at it. The farmer would come back and say, no, the right to natural gas consists in the right to mine it, the right to extract it, the right to burn it, the right to generate electricity in it. That's my right. That's what my property is, the right to burn it, to extract it and to burn it. So those 2 points, that's still good law. Now, the law has changed a lot in the intervening almost 100 years. There's been not a profusion, but enough case law that we have some sense of whether a regulation can still amount to a taking. And these are the 3, for our purposes, the 3 seminal cases. There's Nolan v. California Coastal Commission back from 1987, Lucas v. South Carolina Coastal Council from 1992, and most recently, Koontz v. St. John's River Water Management District. And none of these talk about the kind of situation we're discussing this evening, but what they all reiterate is that, yes, sometimes a regulation can amount to a taking. Sometimes a regulation can go too far. In fact, that case I just mentioned, this one, Pennsylvania Colby Mahone, it got a name check in this case. So the Supreme Court has recognized, has sort of reminded us all that Pennsylvania Colby Mahone is still good law. It's been fenced in a lot, but it is still good law. Right. A reminder. Those of you with biblical knowledge will be familiar with the phrase, I see a cloud the size of a man's fist on the horizon. I don't see, it's not in the sense of trouble brewing, but it's something that we need to be mindful of. And this is what I wanted to, the exception I wanted to tell you about. Remember, the federal law says we can have primacy in Massachusetts over this underground injection control program if we satisfy certain standards. So we have primacy. Our Department of Environmental Protection is the body that now regulates Class 2 wells, underground injection control program across Massachusetts, with one exception. Here's the exception. The UIC program, Underground Injection Control Program, for all classes of wells on Indian lands in the state of Massachusetts is administered by the EPA, by the Environmental Protection Agency, by the feds. So, where are the Indian lands in Massachusetts? Good question. There's no overlay map. There's no way you can look at and see clearly delineated what are the Indian lands. But what we do know is that wherever those Indian lands are, if there's natural gas under there, in the unlikely event that there is and somebody tries to extract it, it wouldn't be the DEP in charge of regulating it. It would be the EPA. Why does that matter? DEP has banned Class 2 wells. EPA has not and cannot. So the reason this is relevant, maybe, is that if someone did discover that it was worth exploring for natural gas in Massachusetts, and if they found some natural gas and somebody wanted to extract it, and it turned out it was on Indian lands, then they could do it and be free of that Class 2 wells ban. So the cynic in me says, where are the Indian lands? It's wherever the natural gas is going to be. A spate of land claims. Attorneys love litigation, but remember, without being flippant, when it became clear that casinos could be built on Indian land appeared. So sort of front load these things. So just a quick reminder, that's how these 4 different topics fit together or don't fit together. We have a regulation that bans Class 2 wells. You can't frack in Massachusetts unless it's on Indian land. Why do we know that? The regulation says so. Is that regulation vulnerable? Yes, it probably is vulnerable, because the statute that said DEP you can ban fracking didn't actually say you can ban Class 2 wells. It gave it a much broader remit, and that much broader remit probably falls foul of the non-delegation provision of our Constitution. Legislature probably went beyond what it was allowed to do in granting the DEP that authority. And somebody could make a good, straight-faced, bona fide argument that the regulation amounts to a regulatory taking. So the short answer is, I do think that the regulation is vulnerable. So if those 3 contingencies ever came to pass, there would only be one situation in which anybody who is opposed to the practice of extracting natural gas in Massachusetts would be worried. One is if that challenge fell in court for the reasons I've just described, or if it turned out that the natural gas was under Indian lands. But the other important thing to remember is no fracking in Massachusetts, plenty of fracking for Massachusetts, 68% of the electricity we generate in Massachusetts comes from natural gas. The reason we're here tonight with the lights on is because of natural gas. So if you're for the use of natural gas, you can feel good about that. If you're against the use of natural gas, think about it. And thank you.
Thank you, Peter Vickery. And I just want to underscore that last point, that even if fracking doesn't happen here in Massachusetts, it is happening somewhere, and we're benefiting from it. It could well happen in New York State. You probably have heard that Governor Andrew Cuomo is under tremendous pressure from industry, from people living on top of the Marcellus Formation who want to cash in on that. Currently, there's a moratorium on hydraulic fracturing in New York, but there's speculation that parts of that moratorium may be lifted. So even if it doesn't happen right where we're sitting, it may happen not too far away. And we're not telling activists to roll over and go to sleep after what Dr. Petch has said, because it's still a reality, and we still have to be concerned about it. But with that, I open the floor to questions and comments to either of the speakers. Yes, in the back.
Yeah, I have a comment and a question. As I understand it, the price of natural gas has probably never been lower than it is now, and there's a huge glut of natural gas. All this movement, all this interest in fracking seems to be really oriented toward trying to develop it for export, where the prices are much, much higher overseas. And my question to Peter Vickery is about home rule, and what impact can that have in terms of whether town bylaws can actually have any true effect in terms of preventing fracking. I live in Pelham, which I don't think has any real potential for fracking, even if Connecticut Valley has minuscule amounts. But tell us about home rule a little bit and whether town bylaws have any real power.
The short answer is I think they would, but they might not withstand a challenge. So in the first instance, I think a town would be free to enact some kind of ordinance prohibiting hydraulic fracturing within the town. Towns do have bylaws to do with something very different, hydro-fracking, as opposed to hydraulic fracturing, in the use of that process to get water. Drilling is something that towns can have bylaws about. So it's not as though this whole field has been preempted by state law. But if the town were to go to the extent of saying, you just can't do that here at all, I think that, well, first of all, you confront the same arguments, the same legal arguments, that amounts to a regulatory taking, and that it goes beyond what the Constitution permits. But I think it would invite a challenge. I'm not saying that you wouldn't be able to do it, but I think that it would certainly be challenged if somebody discovered natural gas and wanted to extract it. And I think it might well succumb to a challenge. And the point you made about prices is an important one. The reason that natural gas is cheaper now has a lot to do with the price of coal. The price of these hydrocarbons are very closely connected. The fact that we're not using so much coal in Massachusetts now, and that regulation has made it much more difficult to extract and burn coal in the United States as a whole, does not mean that we're not mining any coal. Actually, we're producing more coal than we were 10 years ago. It's all going somewhere else to be burned. So that's having an effect on the price of coal, and there's a connection between that and natural gas. So these are moving targets, but I think that the home rule question is an important one. I think a town would be able to enact a bylaw. The Attorney General would probably sign off and say you can do that, but it probably wouldn't withstand a constitutional challenge.
Yes, this is for Dr. Petch. I think one of the reasons I got involved with, or was concerned about this, was this conference last year at UMass. And I thought that the phrase at the end of the report, I thought from the USGS geologist, was the phrase that was inserted at this time, due to the current technology and economy of drilling, it's unlikely that there would be any assessment, exploration, or extraction. So I think that's what caught a lot of our attention, was the at this time, with the speed of technological changes, and then with the appeal that the industry has for extracting everything from everywhere. It seems that it made it seem like, well, it's not likely, but there's this clause, and it wouldn't it be a shame to have been sitting around and then the landmen show up, shortly thereafter, and your neighbor's selling this off. And so I think some of us are here thinking, well, probably not likely. Why don't we think about bylaws, et cetera, strengthening state laws, whatever. So I guess the question for you is that phrase and what you know about that, or where that was coming from, and addressing it.
Sure. So I would imagine that is just careful writing. At this time, given economic and technological limitations, or to paraphrase, we just had a question about the economics of natural gas. Natural gas is really cheap in this country right now. The prices would have to rise not by a factor of 2, not by a factor of 10, but I don't know how much, to make the minuscule amount of gas worth. It would have to be equivalent to maybe the price of gold or something ridiculous like that. I'm extrapolating, but something like this. And likewise, the technology does not exist, and companies are working on this. Clearly, in other areas of the country and others of the world, there's a lot of incentive to improve this technology. I gave you one example about the horizontal drilling being confined to a particular layer within limits. We can't drive that car through a really narrow bed. And there are advances in it, but they're just not happening very quickly. And they're not happening very quickly because the economic incentive is not there. And it is such a long way off for the prices to rise for natural gas until any of that could be possible.
Yes, in the back.
So this is a question for both of our speakers tonight. While the benefit of natural gas, the lower price and all that might be true, and also saying that 68% of the electricity is generated from natural gas rather than coal. All that being said, if those three remote contingencies do occur, and if the puzzles that we piece together do fail and the energy industry wins, given the amount of water it takes to actually generate the natural gas, especially from unconventional gas. Last year alone, a report came out saying that 280 billion gallons of water being used for fracking gas. And then the IPCC, the Intergovernmental Panel on Climate Change, the report, fifth assessment, just came out last month, saying that the CH4's global warming potential, or the heat trap, is far higher than originally thought. So given all this, and then there's of course a lot of studies saying fracking, as exciting technology as it may be, cannot prevent leakage, certain level of CH4. So my question for you two is, say all the other laws fails and the energy industries wins, do we have other environmental laws, or that actually beat the Clean Water Act or air pollution, all that? Do we have other tools in the box that can fight the energy and to actually get a real picture of natural gas extraction, not just looking at the benefit, but also to see the environmental, social, and health aspect of the costs?
Sounds like a long question.
So that's a great question. I'll take one part of it. So the attorneys general from a number of states have issued an intention to sue letter saying to the Federal Environmental Protection Agency, you should be regulating natural gas because methane is 25 times more powerful driver of climate change than CO2. So that's one avenue for folks who are opposed to more natural gas extraction in the United States. Some attorneys general are at it, are going at that with the intention of getting the EPA to effectively issue a nationwide fatwa against fracking. And the reason that the attorneys general, or Democrats, the reason those Democratic attorneys general are doing that is because they know that the Congress won't prohibit the process. There is a bill that makes an appearance every session that is called the Frack Act, I think F-R-A-C, that would undo that 2005 law, the one that said the underground injection control program cannot prevent hydraulic fracturing. So that 2005 law is in the sort of crosshairs of this bill that keeps getting filed but is essentially dead on arrival. It's not going anywhere. So the Republican majority in the House of Representatives are opposed to that bill, and the Republicans have a pretty substantial majority in the House. And so that bill is not going anywhere for the foreseeable future. So one avenue, if you're sort of ruling out the national legislative route, is focusing on what the attorneys general are doing, trying to force the EPA to do what Congress won't. That said, even if they're successful, I think there's a great, in a lawyer sense, great challenge to the EPA that would follow from that. If the EPA is doing something that Congress has specifically said it must not, that's pretty unconstitutional. That's the EPA arrogating to itself the legislative power. And I know that this administration is in some ways really pushing the envelope when it comes to executive actions that are perilously close to legislative actions. But I think that one would not succeed. I don't think that EPA action we're talking about here, EPA regulating hydraulic fracturing in order to do what Congress has specifically refused to do, I do not think that would fly. That would be, in my opinion, patently unconstitutional. At the state level, lots of states where there is an abundance of shale gas, a lot of activists are pushing statewide bans or at least tight regulations to take care of the water issue and the disclosure issue about the chemicals that are involved in the slick water, the water that comes back up, and how you dispose of it. So there's a lot of activity at the state level to try to regulate or prohibit hydraulic fracturing. But there isn't a state where a ban is likely to come into effect anytime soon.
Thanks. Yes. I think this would be for you, but I'm not sure. I was hoping to hear more of whether the documentaries and whether the Hollywood movies that portray fracking as incredibly harmful are true. And when I hear them characterized by proponents, they characterize them as not true. They characterize them as left-wing propaganda or, anti-fracturing idiots who don't understand that it's really not that bad. And I'm just wondering, is that a question you can answer?
I don't watch movies. So I can't. I know of some of these. There was something called Gasland. Then there was something that just came out this year that starred some big name movie star who I can't remember. So I can't address those. I can address some of the scientific evidence we have that associates contamination problems with hydrofracking or with natural gas. I'm trying to be very careful about this. There is a fairly recent study in the Proceedings of the National Academy of Science. It was done by some scientists at Duke, I believe, that detected trace constituents and maybe isotopic signatures of those constituents in shallow groundwater reserves that could be tied to some of these deeper shale gas formations in Pennsylvania. What that study, so people read that and said, aha, shale gas drilling is allowing this deep frac fluid to penetrate upward into our groundwater wells. What that study could not address is if the introduction of those trace element signatures was naturally occurring before any of the drilling happened or not, because they looked for it after the drilling. You can't go back in time. Certainly, there's a very nice, and by the way, there's a really nice resource on National Geographic's website about shale gas and shale gas exploration. And NPR also, in the last year, had a very nice story, and that showed up on their website, that in Pennsylvania, there is a number of cases where, because of just the massive number of shale gas wells that have been drilled and the poor record keeping, because Pennsylvania now is a shale gas fracking state, but I'm from Pennsylvania. Let's remember, oil started in Pennsylvania. So there's 100 plus years of history of oil and gas drilling. The records for where the wells exist or existed are not well kept. And there's been a number of cases where the fracking fluids with this high pressure has caused releases, where one new well has intersected the region of an old well. And there's pictures of it look like a geyser going off in the middle of the woods where no one knew an old well existed. That's a geologic problem. That's somewhat a regulatory problem too, that we don't have adequate records of where all these wells are kept. If in a perfect world, if the technology is deployed absolutely correctly, and casing is done correctly, and cement seal is done correctly, and disposal is done correctly, it is not a technology that should be introducing contaminants into a groundwater system. I don't know of things that work perfectly, so that there will always be flaws.
I would like to direct the question to the person whose name I'm blocking on. But anyway, as a geologist, I wonder if you could comment on what has been proven to be a connection between fracking in one part of the country and earthquake resulting from the fracking. And the investigation has been clear-cut that it did cause the earthquake.
Yeah, that's Kate Karanen, who actually she gave a talk at UMass back in the spring semester. She's a seismologist. I believe she's now at, is she at Lamont or Cornell? But she was at the University of Oklahoma. And she, as well as a number of others working in this area, they have clearly shown that through the intense oil and gas exploration in Oklahoma, there are earthquakes that have occurred. Low magnitude, but I still would not have wanted to be there. Magnitude 5 is still enough shaking to make me uncomfortable. That was temporally and geographically associated with fracking. It's a different geology than, say, in Pennsylvania and New York. That the wells that they're targeting in Oklahoma, if I'm not mistaken, are shallower and in a more faulted system than has been found with fracking in Pennsylvania and New York. That geology actually in Oklahoma is probably more similar to what we have here in Massachusetts. And so there is a connection between this fracking.
We do need to be thinking beyond their own backyard.
I was just curious, like, with all the things going on right now, my question is probably directed towards Mr. Thickery. There's a lot of irritation with the federal government, and so if we went back to the idea of nullification, is that ever going to start meaning anything?
Remind us what nullification was.
Well, nullification is the idea that if the federal government is not attending to the Constitution the way it should be, then the states don't really have a union, and then they don't have to abide by the laws of the federal government. I mean, if the United States is united, it's united under the Constitution. So it's a really old law.
Yeah, the nullification crisis. Well, I hope not is the short answer. When I became an attorney, I took an oath. I swore to uphold the Constitution of the Commonwealth of Massachusetts and the United States. And when I became a citizen, I took the same oath again. So I'm a loyal citizen of the United States of America, and I would be not disturbed, I'd be outraged if anyone tried to secede or claim that any state had any right to secede from the Union. Short answer is, my political opinion, it doesn't matter how kind of gripes we have with one another over the politics of the Affordable Care Act, or the budget, or the debt ceiling. We are one nation, we are one union, indivisible, and nullification. Now, sorry, you've given me something to keep me awake at night. I hope not is the answer.
Let's take just one more question. Yes.
This is in a broader context. If the majority of our electricity is generated by natural gas, we're opposed to oil, we're opposed to nuclear, we are opposed to siting windmills, we are opposed to siting some solar arrays. If we had this meeting in 50 years, would we be using candlelight? Because we would have no energy. At some point in time, we're going to have to think in terms of how much energy do we need. We're going to adopt new technologies, but we failed to look at the underlying question, or the underlying problem. And the underlying problem is we just have too damn many people in the world. And until we start addressing population control, we're not going anywhere.
Well, given that was a rhetorical question to some degree, it was our last question. It kind of leaves us holding, for each of us, some of the deeper questions that we all have to be asking ourselves and as communities. So, thank you. It'd be a good way to wrap up.
Could you comment on, this is being filmed, and I know a lot of people who couldn't come tonight. Is this going to be available through
The
community
people
access
coming are
television?
the Frontier Community Access Television. It will eventually be on their video on demand channel on their website, which is fcat.tv, in maybe a week or so. Is that right? Mm-hmm. So people who wanted to come tonight and couldn't will be able to see it that way. I just want to thank again both of our speakers, Dr. Stephen Betch and Attorney Peter Vickery, for sharing their knowledge and expertise. If these types of programs are interesting to you, we have a little bit of information on the windowsill about the Sunderland Energy Committee. And also, if you haven't seen the article that was in the Valley Advocate a couple weeks ago by Stephanie Kraft, we have copies of that as well about the fracking question. Thank you all for coming, and